So just to recall, to find a z-score, we take the value minus the mean and then divide by the standard deviation. Say instead, though, we wanted to find the value. That means we need to solve for x. To solve for x algebraically, I'm going to multiply the standard deviation on both sides. So those cancel. And so I have x minus the mean equals z times the standard deviation. And if I add the mean to both sides, then I will solve for x. And so that tells me x is equal to the mean plus the z-score times the standard deviation. This transforms a z-score into an x value. So this is the formula used to transform a z-score into the x value. Okay, it'll be on a formula sheet, but you may want to write it down just so you've got it. Okay. Now, a vet records weights of dogs. The weights are normally distributed. The mean is 52 and the standard deviation is 15. You want to find the weights that correspond to the z-scores. So how do we do this? We're given a z-score of negative 0.212. What that interprets, remember, z-score is how many standard deviations away from the mean we are, right? So it looks like we're below the mean of 52 pounds, so this is a pretty lightweight dog, okay? So not too light, but certainly less than 52 pounds. So how do I do this? The value equals the mean plus the z times the standard deviation. So the mean is 52 plus z, which is negative 2.12, times the standard deviation, 15. When I multiply this out, what do I get? I get 20.2. Now, if z equals 0, remember, you can have a z-score equal to 0. That's whenever the value is actually equal to the mean, but we'll work through the math anyway. The mean plus ZO, so this is going to be 52, plus 0 times 15, 0 times 15, 0, so this is just 52. Okay, so weight, we're going to say the weight is in pounds. And then here, this last one, mu plus z standard deviation. So 52 plus 3 times 15 gets me 97 pounds. So that's a heavy dog. All right. So those are my numbers. Those are the weights. Okay, so that's how we convert a z-score to a standard deviation, using the standard deviation and the mean, convert the z-score to an x value, okay? So suppose that SpongeBob wants to have a dog that is in the upper 10 percentile, so the upper 10% weight class. What is the weight, the lowest dog, or what is the weight, what weight is the lowest SpongeBob is willing to have the dog weigh? All right, so suppose, now I said SpongeBob, I guess this is just Bob, huh? But anyway, what if we did a picture? What do we know? We know that we want the dog to weigh, so this is a z-score of 0 in the middle, right? We're looking for a z-score. We want the dog to be in the top 10% percentile. So that's the top 10%. What does that mean? That means that 90% is below it. So I need to go look up a z-score that has a 90% inside. So go find Waldo with 0.90000. So when I go look for that, I'm in the 9s. Okay, this one looks like the closest. Right? So between this one and this one. Now this is 0.0015 away, and this is 0.0003 away. So I think I'm going to use that one. So that corresponds to 1.2, 1.28. Okay? So this gives me a z-score 1.28. Now, that's helpful to us because now I can use my value, so which is mean plus standard or z-score times the standard deviation. So this is 52 plus 1.28 times 15. And when I multiply this out, I get 71.2. So what does that mean? The lowest weight a dog can have to meet Bob's requirement is about 71.2 pounds. Okay? Because Bob says that they want a dog that's in the upper 10% weight class. This is the mark. Now, could your dog be more than 71.2 pounds? Sure. The dog could be 100 pounds and it would be in the upper 10 percentile. Okay? So anything, this is more of a lower bound. This is the lowest number possible. Okay? So the lowest weight is the 71.2. You could have a dog that weighed 200 pounds if that's what you wanted. You'd definitely be in the top 10%. Okay? That's a huge dog. All right? That's like a little horse. All right, guys.